All right, you can see the screen? Beautiful. So today we're going to get into a different prompts. You should have this in your resource, this notepad file, okay? That's the commands that we'll be doing. And this resource file that I have here, and we're going to go over the commands and what they do and things like that, okay? And it also has other things as well as DHCP configurations in the switches, routing protocol configurations like RIP, EIGRP, OSPF, and then different ways to configure EIGRP. This is multi-area OSPF and keyboard shortcuts and show commands. So this has a lot of helpful commands that we're going to do. So we're going to do at least the first part of this, but I would like to create an actual topology, but I want to show you guys how to do this and why we're doing it. All right, so now is where the fun really begins. Okay, at least for me, now we're actually configuring, we're actually doing things, not just talking about some OSI models or anything, even though it's important for your certification, but definitely this is something that we need to address, right? Give me just a second. I got a message here from, okay. Let me reply to that. So yeah, so this is what we're going to do today. I'm going to wait a little bit just to see if some more people come in. Have you guys gotten the resources that I sent you?
Where did you send, Les?
There's a WhatsApp. I sent it to Network Teams. There's a WhatsApp group called CCNA. I send it there, and then their support group. I guess you guys have another WhatsApp group that I'm not a privy to, that they send it to you guys. It's some sort of WhatsApp group, I think. I don't know. I know that's why I said mine.
So it is uploaded on the portal, but the thing is, we are only I am only able to download some of the files. So command files, I can see there, but I cannot download that.
Well, it's not a command file. This is a notepad file.
Yeah, let me share you. Like the command, notepad file where you mentioned the command. I'm unable to download that file.
Oh, okay.
This notepad.
Yeah. Gotcha. Okay. All right. Well, at least it'll be in you have access to the recordings, I'm assuming.
Yep.
All right, so at least in the recordings, I'm not going to go fast. Okay. I'm going to take my time since this is the first configuration they're going to do, and you do need to learn the navigation through it, because in the CCNA, you have 3 labs. If you're unlucky, you got 4. All right, but it's normally 3 actual labs that you're going to have to configure. All right, it could be anything. It could be from a routing protocol to an access list to NAT to who knows. All right, so I need to make sure and that you know how to navigate through the operating system of the router. You're not going to have to worry about connecting to a router or anything like that. Basically, in the test, you're going to click on the router itself and it'll open up. All right, or I know when I took, I had to renew my CCNP last year. I did it the way that it was a split screen, and then when the lab pops up, already the 3 routers are there, and all you gotta do is just click on the tabs for the routers. But you need to know what prompt you're in, what commands you need to type on that prompt. All right, so and the show commands are very important, because you need to get to that. You need to see things quickly. And this is why IP addressing was one of the first things I wanted to put out there, because you do not have time to do math in the test. You don't have time. You're not going to be calculating any bandwidth or anything like that. All right. You're going to be there to answer multiple choice questions, but the weight of the exam is on the actual simulation, the lab. Okay. Based on my experience, when I was back in the US, that I would teach a brick and mortar. I used to teach in universities, colleges, and all that. And in those times, I had a student that actually missed. He ran out of time. He missed 10 questions. He got all the labs, and he was very confident, and he passed the test. So the weight is on the labs. I'm just basing this on my experience for over 20 years that I've been teaching this, that this is what's going on. All right. So let's wait maybe 1 or 2 more minutes, and then we'll get started, because I think this is the only people that are coming. All right. But yeah, so definitely, whatever book you have, make sure you read it from cover to cover. When it comes to the OSI model, the TCP/IP model, the Cisco 3-layer model, any guidelines like that, even the last couple of chapters where they talk about the network automation, when it talks about JSON and REST APIs and those different languages, just for you to be able to describe them, to be able to identify them. You're not going to be configuring anything that deals with automation, just understanding the terminology, because this test is a lot of terminology. So reading the chapters, doing the questions, that's number one. And then the labs, obviously, I want you to be able to apply the knowledge that you're getting here to what you're going to do at your workplace. So this, now that we start configuring, I'm very passionate about, because you can have a piece of paper, but if you don't know how to do the job, then that's not good. And you cannot leave me with not knowing what to do. That's not an option. All right, let's go ahead and get started. All right, so we got the packet tracer. All right, the routers that we're going to be using are the 2911. All right, so when I come here, let me back up. So in the packet tracer, this is your work area. You have routers, switches, all right, all different internet networking devices here. You can select them down here. Here's your routers. They're your switches. Here you have hubs and repeaters, which we're not going to use. Here, when we get to the wireless part of the class, we'll be using the controllers and the lightweight APs and things like that. And here's a firewall, which we'll not be using. I may use it one time just so I can show you, but they'll ask you about what is a firewall and security protocols and stuff like that. But as far as configuring or anything, you don't have to, but I want to show you. All right, so today we'll be creating a little lab. So we're going to take out the 2911 routers, and every router has something different. Like I can tell you right now, I believe is this PT router right here. I can show you. See how this router has fiber connections? All right, you can use this to create a lab with fiber. This router here does not have that. These are all modular routers, which you can get these modules on the side and bring them in. And as a matter of fact, I'm going to do that just to show as an example. Here you see the switch button, this power button. I turn it off, and I'm going to throw this HWIC card, and that is a serial port. All right, there's 2 serial ports. These are called smart serials. All right, that's going to be on there, and you have your console. I can't really see. You have your console, your auxiliary, and your gig ports. All right, here and here. All right, so that's what you need to be concerned with. Once you turn on the router, then you'll see this information, but we'll get into there in a second. So we're going to take out 2 routers, 2 2911 routers. I'm going to go back in, turn off the router, and I'm going to get this WIC card. And let me just read you what it says. HWIC 2T is a Cisco 2-port serial high-speed WAN interface card. All right, so I'll show you just so you can see the difference between Ethernet and serial. Not that you're really going to be using it on your test, but you need to know it. All right, and then I'm going to get a layer 2 switch for right now. So I'm going to take out the 2960, which is a layer 2 switch. What does that mean? That means that they cannot do any type of routing. They don't have routing capabilities whatsoever. And this is going to be a thing of the past pretty soon. You're going to be using multi-layer switches that work at the layer 3 of the OSI model and layer 2. These just work at layer 2. They just deal with MAC addresses. Where's the other switch? I got them out there. And you get PCs. I click here, categories, right? And devices. So I'm going to click a PC and then another PC. Now, the way I plug in my cables, we talked about cables yesterday. So from here we need a straight through from the PC to the switch. So I click on this lightning bolt right here, and then we have our copper straight through and our copper crossover. Remember, dissimilar devices, straight through, similar devices, crossover. So from PC to switch is a straight through. Now I use the cable. I'm not going to cheat, all right, because using this will do it for you automatically. Okay, I don't want that. We're going to use the copper straight through, so you get used to that. And then you're going to select the Fast Ethernet 00, click on the switch, And I like to use the lower ports, meaning from 15 and below, for the end devices. Okay. And then for switch to router, I like to use higher ports, which is still a straight through cable. And I like to use higher ports. So in this case, since I know that router has gigabit ports, I use gig 01 here to gig 00 here. There's a method that I use because I don't want you to get confused. There is a protocol that you will learn to use, which is called the Cisco Discovery Protocol. So you can see your neighbors that are next to you. And there's another one as well, because that's particular just to Cisco, proprietary to Cisco. The other one is LLDP, the Link Layer Data Protocol, which does the same job, but it goes across vendors. But we'll be using that as well. And I'm going to do the same thing on this side. Fast Ethernet 00. And I have my chat open, so you have things you can go ahead and chat away. I think I have my chat open. That's 01. I need to look at it again. Gig 01 to gig 00. Oops. And then finally, we're going to use a serial connection. So I'm going to come here and I'm going to select the one with the little clock on it. And the one with the little clock is considered the DCE portion of the connection. These are crossover serial cables that we're going to use. And again, just to show you, normally I will put in a crossover. Oops, I picked the wrong cable over here. I will use a crossover cable between the routers to make it straight Ethernet. I'm not going to do it this time. I want you to see that particular cable. This is something that we came from. Some people still use it, believe it or not, but just so you can see it. So we're going to be here. We'll pick the S000 to the S001. Now, I do this because in a lot of places, they like to put the same interfaces on both sides. I don't like doing that. I want you to know exactly where you're going to. And when you do the show CDP neighbors or show CDP neighbor detail, you need to know what interfaces you're going to. So this is how we connect the devices. And again, manually connect the devices. We're not going to use the console cable. I showed you the console cable yesterday. We're going to go straight and go click into these devices and start doing the configurations. We'll start with the routers. All right, and then we'll go into the switches. All right, and see how far we get. But I do want to explain that notepad that I showed you, this one right here. I want to tell you why we're doing this. What is this? I want to explain to you these commands in detail. Okay, at least right up to that line right there, so you understand what we're doing. Okay, I can't hear a voice. Can you hear my voice? Can you hear my voice?
Yes, yes.
Yep.
Right, yeah.
Okay. If Sarath, if you can, I don't know, turn up your volume, make sure you have the right speakers selected. That could be an issue. That could be happening. Please check that. Oh, I should chat that probably if you can't hear me. Check your volume settings. All right, so here we go. So the first thing we're going to do, we're going to come into the router. All right, so you can see where the router is. All right, and we're going to maximize that. So when you first run a router, let's say you just bought it, there's 0 configurations on the router. It comes up because we're working with a router, you have 4 components you need to be aware of. You have your NVRAM, non-volatile memory. You have your RAM, volatile memory. You have your ROM, which is read-only memory, that it's built internal into that router, and your flash, where that's where your operating system sits. So you never want to be in ROM. You look towards ROM for the boot up process to look for the operating system and the configurations. But when you're up here, because the NVRAM is your startup configuration. Think of your non-volatile memory in your router as your hard drive. Okay, that's where you're going to be saving all your information to. You're going to be working in RAM, just like if you're inside a Word document or PowerPoint or whatever, you're working in RAM. So you want to save as you go, and I'll show you how to do that. You want to save as you go because you never know if there's a brownout or a complete power outage and then you lose all your information because you didn't save your information. That wouldn't be a good thing. All right. So when you boot up at first with a blank router that's not configured, it's going to come up like this because it looked at NVRAM at the startup config file and did not see any configurations. So it said, okay, do you want to enter the initial configuration dialog? This is setup mode. This is called setup mode. And if you say yes here, that means you're going to follow a little wizard, type in the host name, type in the IP address, we're not going to do that. So you always answer no here. Let me click in here. You always answer no. I just type the letter N and hit enter. All right. And when it says press return to get started, just hit enter. And now you're here. This is called user mode. User mode. Now in the packet tracer, if you want to know what you can type underneath any one of these prompts, just type a question mark. And by no means is this everything you can type. Now that we're going to go through this basic configuration today, once we continue to configure, more than likely I'll open up Eve and G, right, which is more realistic routers, more iOS commands. But for now, this is fine. And if you're working with a packet tracer for the CCNA, that's fine. But just so you can at least see the difference. You can see the difference. All right. Oh, something popped up over here. I'm sorry. All right. So user mode. When you see this symbol, that's user mode. You can't do much if you're in user mode. All right. You can't do much. So you type now, you want to get to a prompt that's always been considered privilege mode. And it's still considered privilege mode, except for your certification. So I'm going to type enable. And you see how the prompt changed, right? It says here, turn on privilege commands. This is considered privilege mode. For your test, in your book, in this certification, they're calling this enable mode because you typed enable or you turned on enable or you turned on privilege commands. So you can call this enable mode for your test. I call it privilege mode, but again, you're taking a test, so know it as enable mode for your test, and then when you go to your workplace, it's privilege mode because you can see it right here. So now, really, you're able to start doing certain configurations. One of the first ones in there is the clock. And if you don't know, look what you can do. Remember I told you you can type a question mark and you can see everything that's underneath there. And sometimes it's long. So you can type the letter C because I know I need to put it in the clock and I can question mark that. So you put a letter and a question mark right next to it and it tells you all the commands that start with the letter C. So why do I want to put in the clock? Well, you want to make sure that all your computing devices, your computers, your printers, everything, domain controllers, anything in your networking, you want to make sure that the clock is going to be set properly to the right time zone. So when you're synchronizing, let's say domain controller servers, that they will synchronize correctly. When you create user accounts and stuff like that, that they will appear where they need to appear. So you want to have the right time on your routers. All right, so clock. And then I'm going to question mark my way right through this. Clock, set. There you go, Sarath. I heard a noise. Set. And now the hours, minutes, and seconds. So for me, it's 10:49, and I'll put in, I don't know, 30 seconds. What else? Is there anything else? Oh, the day. Day of the, what is it? Day of the month for me is 8. Okay, then what? Then the month, well, we're in December. Cap, let's put a caps, December. And then the year, which is 2024. That's it. And if you want to know if that's it, type question mark. When you see this, that means you hit enter. Okay, well, if you want to type it on the chat, for me, it was showing muted. Oh, okay. No problem. All right, so what does this mean, CR? What does that mean? Anybody? It's a cool thing to know. Now you need to know it, but what do you think CR means? Carriage return. For those of you, I guess, that are near my age, if you're typed on a typewriter and you went like this, that's what a carriage return is. Remember, you're typing on a typewriter and you go like this? That's a carriage return. That's what that is. That's exactly what that means. So when you see that, you can go ahead and hit enter. There's no else command you need to type. So that's the clock command, but there's more than one clock command. All right. The next one we're going to look at is called terminal history. I'll type in again the letter, question mark it. You got telnet, trace route. I want terminal. And then I'm going to question mark again what I want. History. Enable and control the command history function. Okay. Because you want to be quick when you configure. So when you do terminal history, you're going to see, when I question mark again, it's going to be a size. All right. And there's how many. What does that mean? That you can use your up arrow key or down arrow key to go through commands from any particular prompt that you've typed before. Instead of retyping the commands, you can use your arrow keys to go back and forth. You need to learn how to work with that. I'll show you here. And also the tab key. If I type enough of the command and I hit the tab key, it finishes the command for me. The iOS is intuitive enough to know, hey, these are the commands that they want to type. It recognizes it. All right, so we'll look at that as well. Now, I put, let's say 50. I think that's enough. Then I'll put 256 commands, but 50 so you can work with. All right, and you type that in there. And you're doing this, remember, from privilege mode, because they will mess with you in the test and they will put the right syntax on the wrong prompt. So when you're looking at a scenario-based question, you need to be looking at this is the right syntax. Okay. Wow, it's the same syntax all the way down. Well, wait a minute. Oh, I'm in the wrong prompt. I'm in user mode. I'm in privilege mode. I should be in interface mode, right? So that's what you need to look at as well. Look at the whole thing. Just don't look at the syntax. Make sure you're in the right prompt. All right, so now we type that. And that's really all I want to do here for the time being. Because here, another thing, let's say I have that. And now I want to copy what I have in RAM to NVRAM, which is the startup configuration, non-volatile memory. I'm going to type copy, startup config, and I tab that. You saw that? To run enough of the command, and I tab it and it puts running config. In the test, you don't have to do that. In the test, you don't have to do that. I just wanted to make an example. In the test, you can simply do copy start. I'm sorry, opposite. Copy run start. Copy what's in RAM to NVRAM. Copy run start. Copy running config to startup config, and you hit enter. Now it's going to come up. Hey, this is the destination file name, and it's in brackets. Whatever's in brackets, if it's one thing, that's the default. That's where it's saving it to. Do not type anything else, or you will create a new file that you want to save it to. Don't do that. So when you see that, you hit enter again. All right. So now you can try this in the test. It's not going to count against you. I like to do from here. I like to do this. WR. Same thing. It's not going to ask me to put it in any file name. WR. You may be able to get away with it in the test. If you type it, it's not, and it doesn't work, it's not going to count against you. But again, for quickness, the less you type, the quicker you type, the quicker you get to do things, the faster you go through and you gain more time. The faster you go through your scenarios, you gain more time. All right, so let's continue. But that's all I wanted to do there. We did the clock and we did the history. Now we're going to go into something called global configuration mode, which actually affects the router as a whole, right? Global config T, which is for terminal, and we hit enter. So now we're in global configuration mode. And now is where I start doing things. There's certain, and I call this, the notepad that I showed you, basic housekeeping commands. Basic housekeeping commands. So I'm going to say host, and I'm going to type in host, and that's really the only command that starts like that, so I can hit tab, or is intuitive enough to know if I want to put host, or I'll put it in caps so you can see it better, host R1, it knows that that's what I want it to do. If you wanted to type the whole thing, host name, you got to type in host, and then I tabbed it, and I'm just going to put R1 again. All right, it's going to do that. That's fine, however you want to do it. A lot of people do it differently. When you start learning shortcuts and you understand that the iOS knows what you're talking about, then believe me, the router will yell at you when you can't do something. It will use a caret symbol to let you know that this is wrong. All right, well, I'll give you an example of that. I say I do host name, host tab, and I put R1 space router, whatever, enter. You see how I put that caret symbol? Because you can't use spaces in the name. You can use hyphens, you can use underscores, but you can't use spaces. So this caret symbol, my router just yelled at me, telling me, hey, there's a problem there. You can't do that. So I'm like, oh, yeah, that's right. You can't use spaces. I come back. That's it. It's not the end of the world. You made a mistake just like everybody else. And keep going. Typo. All right, so the next thing, there's another clock command. We put in the what? The time, the date, right? But we didn't put the time zone. So here we do clock, time zone. I'm in Thailand. Well, question mark. It's a word. This is just a word. I can put Bangkok, I put Thailand, whatever, Thailand. And then here they want the UTC. I think mine is +7, I think. Oops. No, -7. Oh, to 7 characters. Oh, I know what the problem is. It wasn't the +7. It was that the time zone is limited to 7 characters. So I'm just going to put Thai, and then I'll put my +7. Really? There you go. Whatever. All right. So again, packet tracer. No worries. There's a lot of things we're going to see in the packet tracer that get silly. All right. So -7. All right. So now I set the time zone. I've set the clock. I know I'm in the host name. Now we're going to continue. Now we need to start securing the router. So what we're going to do now is create privilege mode passwords. Meaning you want to go from user mode to enable mode, user mode to privilege mode. Okay. You need to put in passwords. It didn't ask me for passwords before. Look, disable. Exit. Disable. I'm back in user mode. Enable. I'm not in enable mode or privilege mode. Config T or conf T. I'm in global configuration. So it never asked me for any passwords. We need to change that. So I'm going to say, by the way, enable password Cisco. Now, obviously, that's not a password you want to create. This is a plain text password that when you type enable, that you're going to enter to get to privilege mode or enable mode, Cisco. That's not very secure, is it? So we want to do enable secret student. Can be the same. Enable secret student. Hit enter. Now that's an encrypted password. That's using MD5 encryption. We're going to look at it right now. They're for the same purpose. So which one do you type? The secret overrides the plain text. Okay? The secret overrides the plain text. So if I log off of this router and to get back in, I need to type in student. Okay? So let's do that. Let's go ahead and save this. But you know what? I don't want to go back to privilege mode. I really don't. Now in the test, you may have to. So you can exit your way back. All right. And then you can do that copy, run start. All right. Or if you're already here and you want to save it, if you do this here, you're going to get an error. Copy, run start. Then no, you can't type that here. Well, you can't type it by itself like that. Some programmer was smart enough to say, hey, let's put in the do command. Do copy, run, start. And now you can do that. Now, I don't think you can do that in the CCNA. Try it. It's not going to hurt you because the quicker you can do things, the better. But now let's see how that works. Let's exit. Exit. All right. Now I'm outside the router. R1 con 0 now available. Hit enter. There's your user mode. Enable. I need a password. What happens if I type Cisco? CISCO. That's not the password. Nothing. STUDENT. Enter. Now let me show you something in case you run into trouble. All right. Let's say you forget the passwords. Let me log off again. Let's say you're labbing. All right. And oh my God, I don't remember my password. I don't know what it is. In the packet tracer, and you can only get away with this in the packet tracer, you go to config, you click on an interface, you go back to the CLI. Now you're inside the router under an interface, and just click exit and retype your passwords. This is just in the packet tracer, okay? Just in the packet tracer. But you see the navigation, right? Enable, config T, or disable from privilege mode to get to user mode again, which nobody does, but enable, and then config T, we're in global configuration. We're not done here. So now what we're gonna do is we did the passwords, but let's look at them. All right, I'm gonna do it from right here. Do show. Now, normally they do run. If you do run, it's what you're looking at in memory and RAM. So you can see here the secret is using MD5, and there is the encrypted password student. This is the plain text password that I did, but I had to type student because this overrides this. So why would you type both? Well, you're taking a test. You need to know how to do a plain text password, and you know how to do an encrypted password. And just in case, again, this is a justification as per the book. All right, they if you have to revert to an older iOS that doesn't support the secret password, you have at least a plain text password. And there you can see my time zone, right? Which is that's incorrect, but that's okay. And then if you hit enter, it just says more. As you hit enter, you start going down and taking a look at different things that exist here. All right. But right now, what we're doing is enough. And we need to configure our interface. Interfaces have connections. There's your serials. Okay. And then we have down here, there's your line count 0. History size is 50. Okay. And we have our line VTY. We will be going in here and doing things, and we'll be going in here and doing things. But if you want to just go to the very end, you hit the space bar, you go up page at a time. That was a line at a time, page at a time, you hit the space bar. Okay. So what do you want to do now? Right. So we want to be able to encrypt every password that we've typed in the past, that we're typing now, or we're going to type in the future, right? That we've typed already. So we're going to do, there's a command called service password, and I'm going to hit the tab key, -encryption. All right. But when you're first starting out, I suggest you type them all out so you know what they are. And then once you're tired of typing, after configuring 30, 40, 50, 60, 100 routers, then you have that committed to memory, tab all you want. All right. So hit enter. And what that does, it is a very weak encryption. And I know, see, that's what I'm used to. Here's another way to get back. Control Z. Okay, takes you back to privilege mode. And I'm going to copy, but I'm just going to do WR. And I'm going to do a show. Instead of run this time, do a show start. Because I always copy everything. So I can look at show start, which is my NVRAM. And you can see now that this plain text password is now encrypted, but it's a type 7. Now let me talk a little bit about this. In the packet tracer, this is it, what you can do. In your book, in volume 2, in the Cisco Press, okay, they talk about you securing network devices. And they tell you type enable secret Fred. That's verbatim on the chapter. Enable secret Fred. There is now a new encryption, which is called either SHA-256 for these type of passwords and script. SHA-256 is a type 8. Script is a type 9. All right. So if by default in a real iOS, you type enable secret Cisco, it's going to be using type 9, which is script. You can manually, and I'll show you It won't work here, but I'll show you what you would type in global configuration. You would type enable algo, my spelling, algorithm hyphen type, and then we choose script secret, and then we type in Cisco. This makes it type 9. Okay, you can type SHA 256 secret Cisco, and it'll be a type 8, which makes it a longer. So this is type 5. This has been hacked already. So it'll be a lot longer than type 8, and type 9 will be a lot longer than this. Okay. But this is the new method, because in your book, and again, next week when I'm inside EVNG, I'll show you this command. All right. But for now, in the packet tracer, you can just do MD5 and then enable the service password hyphen encryption to encrypt all other passwords. And you can see right here. So any password that I create now will be encrypted by this command since I turned this on. This was originally said no service password hyphen encryption. So if I want to turn this off, I say no service password encryption. If you want to negate something, you put no in front of it. All right. So we're okay with this, these passwords. All right. So the next thing is we're going to create a banner. But the banner that there's many banners. The banner that you're interested in is the message of the day banner. Let's look at that. Banner, message, and let me just show you. Login banner or MLTD. Message of the day. That's what you're interested in. Now, there's delimiting characters that you got to type in here. So you got to be careful. You see it doesn't work here. So what you're going to do is you're going to say, okay, I'm going to start it with a pound sign. There's symbols you can use. And the message is in between those delimiting characters. So I'm going to say, you're not going to say this. It's going to be some legal message, some reading something. Stay out. Well, let's do something nice. Need help? Call extension number 555. Hit pound. Now that's a problem. And they'll probably give you something like this when they talk about this. Whatever you start with, you got to end with. But I typed that earlier, didn't I? So really, the message ended right here. And that's a way they can trick you or test you in the test. So really, if you see this being typed, your message, all they're going to see is need help, call extension. That's it, because it's a number sign. Enable secret password is MD5 encryption. In the packet tracer, yes. In the higher iOSs that use an EVNG or GNS3 or CML2 real routers, if you type enable and you have the latest iOSs, enable secret and whatever password you decide to type, let's say enable secret mango, that's going to be a type 9 by default, type 9. But in the packet tracer, and it's not the latest iOS or anything like that, this is a program, so they're still with the MD5. I hope that answers that. All right, but here, that will be the message. So that's not what we want. So how can we fix that? All right, so instead of starting with a pound sign, we all like money, right? Let's start with the money sign. And then we say, need help? Call extension, number sign, 555, and then end it with that. That's good to go. That's okay, right? And let's save it. I'm going to use the do command, and I'm going to use the WR command. Instead of doing do copy run start or going back to privilege mode, right? Because you can also do this. I'm going to show you another way you can get back. End. Takes you out there. And then if you do exit out of here, right? Watch what happens when I hit enter. Need help? Call extension 555. Obviously, that's not going to be the message that's going to reach you. It's going to be some legal warning or some just, hey, get out if you don't belong here. Enable. Password, that's student. and now you're there. Global configuration, and now you're in global to get back in. You cannot go from privilege mode, meaning here, you cannot go from this prompt to an interface. You can't do that. You have to be here. This is like your middle ground, right? Global configuration, so you can navigate to other places. All right, so we put in the banner. Now we have a banner. But you know what's annoying? That every time I exit out or do something, I never, it's like it interrupts my typing. I see like a blank space. There's some things that you need to type first before all this, okay, that I do. If they don't ask you for this in the test, don't type it. This is for your own benefit, all right? IP, or I should say no IP domain. Now it's either, I always type lookup, okay? That's what I've been typing for forever. Apparently now in the iOSs, you can just use space. So this is my suggestion to you. If you have to type this, no IP domain hyphen lookup, or you need to turn this on, IP domain lookup. And what is this? Why do I want to type this? I make a lot of typo. And that's a problem when you're configuring. Because if the router thinks that it's a host name, right, or fully qualified domain name or whatever that you're looking for, it didn't understand the command, it's going to broadcast out through DNS, which you don't have configured, with a 255, layer 3 broadcast, all 255s, looking for that thing you typed, that typo. And you're going to be sitting there like this, twiddling your thumbs until it times out. So I do a lot of typos. So I turn DNS off. That's turning the DNS lookup off. So if I make a typo, it just goes to the next line. Now, unfortunately, if it's not that easy, you're still not done. No IP domain lookup. Another thing that's a nuisance, but it's needed, the router will give you feedback. Okay, so when you turn on an interface or you configure something that says, hey, this has happened. Hey, this interface went up. Hey, it's giving you syslog messages. Do not turn off your syslog messages. What you need to do, since you're in through the console, remember that I said R1 console now available? You're going to go into that line console 0, okay? And you're going to say login, too many G's, login, SY, tab, synchronous. Here in the packet tracer, this command ends right here. If I do a question mark, there's no more to type. That's it. When I show you, you're going to type this, login synchronous, level, all. What is that? As we know, syslog messages from 0 to 7. There are different messages that pop up if it's critical, informational, error, whatever it is. We want to see those. So we put that. So we still want to see it, but in the packet tracer, you can't type that. All you can type is this. This, for me, I like to type it because I hate when I'm typing and the router pops up and part of my command is up here and the other part is down here. I don't want my typing to be interrupted. I want to be in sync at the same level as the prompt. Okay. So is this related to no IP domain lookup? What, the login synchronous? No, the login synchronous is these are two commands that I type. So when I'm configuring, I don't get interrupted. The no IP domain lookup is DNS. That's one thing. The login synchronous is basically telling the router, when you give me syslog information, when you pop up with this informational message, whatever it is, don't cut my command in half. Keep me at the same level. So now when I type commands and hit enter, if it gives me a syslog message, I'm going to still be at the same level. My commands will get interrupted. So two different commands for two different things. Domain hyphen lookup is to turn, no domain hyphen lookup is to turn off DNS. Login synchronous is just not to interrupt your typing, meaning it will cut you off in the middle. Does that make sense? Okay. All right. So that's one thing that I always do before I start typing because I know my typing skills. All right. So that's that. Now, one of the things that you want to do is create user accounts. User accounts. Username, I'll put mine, LDS. Okay. And then where's question mark? So you can leave it with a password. You can do username, password, and put the password. Okay. Or look, it's telling you to hit enter now. Now, this is what I'm actually testing these things discovered, which is scary. Okay. You don't want, when you're creating usernames on your router, and when they ask you to create, which they won't, but when you're looking at them, maybe it's a scenario-based question. When you create a username, please put privileges, and privileges will be from 0 to 15, 15 being the highest administrative privilege. But guess what? Look, I can stop right there. I can just hit enter. And you know what happens? Now, I've only tested this on EVNG, on CML2 and things like that, not here in the Packet Tracer. But this creates just a username with no password. And I can telnet, when I say login, you'll see it when we do it. When I say login local and I tell it to use the local username, it'll let me in. Now I don't have any privileges because I didn't put any. So I'm stuck in user mode, the little greater than symbol. But the scary thing is that it allowed me to do that. So be careful. Be careful when you're typing. Yeah, be careful when you're typing. When you're creating these user accounts, please put privilege levels. Please put passwords. All right. So privilege level, I'm going to put myself as highest privilege level so I can do whatever I want. And then the password. Now here, it says 0 or 7. If you 0 means plain text. 7, if I type in 7 and type a plain text password, it's going to be an error. I'll show you. And I'm going to put in Cisco. It says that's an invalid encrypted password because that's not encrypted. You literally need to type an encrypted password. So since I know I turned on service password hyphen encryption, I can put 0 here for plain text, put in Cisco, and I'll be okay. All right. And I'll be okay because it's going to get encrypted with MD7. Not that's any good, but at least we'll do that. Here as well, that algorithm type, you can use it here as well. Okay. You can use it here as well. All right. So now we created a username and password. Let's go into the lines now. Line, we went into here before for login synchronous, but there's other commands you can do here. You can say login local. If you just type login, it's going to prompt you just for a password. If you say login local, it's going to prompt you for a username and password. That's the difference. Because I could have stopped right here. Just type in login and hit enter. But then it's just type in the password. Whatever password you decide to put on here. So since I don't have a username, let's say, I will put in, I'll call this Mango. Oh, sorry, not Mango. Password Mango. So that's me setting a password on the console line. But if I were just to type this, I then would need to type that. But since I type login local, I need to type in username and this password. Okay? That's what that means. Also, and we're going to look at all these, don't worry. The next one you want to type in here is exec hyphen timeout. And you put, let's say, 10 minutes. The first one is minutes. The second one is seconds. 10 minutes and 45 seconds. What does that do? If you're making a console session to the router and you're not typing anything for 10 minutes and 45 seconds, your session you'll be kicked out of your session. And this is something realistic that people do because people just create these sessions and they leave them open all the time and there's nothing there to kick them out. So you need to do this. All right. All right. Now let's go to the telnet lines, which is the VTY lines. And what is telnet? That's a way that you can remotely get into another router. Telnet or SSH. So they're called the virtual terminal lines. The default lines are 0 space 4. Okay. The maximum on the packet tracer is through 15. So I'm going to hit enter here. I'm now there. I'm going to type The same things I type in the con, I'm going to type in the VTY. Login, local. Let's put a password in here too, which we're not going to use. Password, mango, just to show you. Login, synchronous. Same thing, because I can telnet in or I can console in, right? So I need to make sure I don't want to get interrupted. I type that. And then exec hyphen timeout, I tabbed it in new. 10 minutes, 45 seconds. All right, let's save this. I'm going to type end. Takes me back to privilege mode. I'll do it the long way. Copy, or the way of the certification. Copy, run, start. Enter, enter. Now that's done. Now let's take a look at it. Show run. You're looking at RAM. There, the host name. Again, things we've seen before. My username. You see that it's encrypted. No IP domain hyphen lookup. There's your banner. It just shows it like this. There's your console line, your history size, your exact timeout, password, login synchronous, login logo. Oh, I'm sorry, login synchronous, password exact. Yeah, there it is. And there's your VTY. I used to configure these. They don't ask you about this anymore. This is where your auxiliary, and we come here. This is what we're configuring. You see here, which one says aux? See how this says aux? That's auxiliary, right? This is your console, line con 0, and your auxiliary. Line con 0 is how we're pretending that we plugged in a console cable or a rollover cable, and we're making a console session. Or here with the auxiliary port is where we're putting in a external modem to the router. These are the actual interfaces. These are USB flash drives, okay? SD cards. That's where in these type of routers, the operating system, that's where they're going to be at. And these cards right here, these SD cards, okay? Let's go back over here. So now we looked at that. All right, cool. We have the telnet lines created. We have usernames on the router. Awesome. But we need to put some IP addresses, okay? So let's see what IP addresses we're going to put. This is why they're submitting the first date. All right. So this right here, right? That's one broadcast domain right here. So that's one subnet. So we're going to use something very simple, a class C address, 192.168.1.0/24. Okay, and then I'm just going to duplicate that here to select something. I just lasso and loop is what it's called. Keyboard combination, Control C, Control V. And I can come over here. I click in it one time, arrow keys, 2.0. So I know that with a 24-bit mask, I have 254 IP addresses available to me. Now, this is where you need to decide. This is where everybody gets stuck. What IP addresses you're going to give to what? So I'm going to bring this over here. PC0. I'm going to go, please don't do it through here. Go to the desktop, go to IP configuration. Statically assigning the IP address. 192.168.1.1. I use low IP addresses for end devices. The higher IP addresses, I use it for my internetworking devices, switches, routers, and so forth. Now I'm going to tab. You saw before on day one. It knows it's a class C address, and I'm using the default mask, so it puts that in there. Now, what is the gateway? My gateway to the outside, my gateway to the public, my gateway to somewhere else. It's that interface right there. But I need to tell the PC to be able to go to that interface. So I got to give the address of that. And what do I use? Always the last available IP address of that particular subnet. We don't have a DNS server, and we don't need to worry about it right now. Okay? So that's my IP address for this PC. That's my default mask for a class C. And this is the last available usable address on the subnet. That's going to be that's my gateway. I close that. All right, so I'm going to come in here to the router again. And now I need to go into that interface. Let's see where we're at. We're back in privilege mode. So I need to get to that interface. So I have to navigate there. So I first need to go to global configuration. Because look what happens if I try to go straight to it. Interface G0/0. It's not going to let me. So if I type config, which is configure terminal, config T for short, I'm now in the middle ground. And then from here, I can go into here. And now look at the prompt. Config if. I'm in a interface. I'm inside this interface specifically. So now I'm going to put the IP address. IP address 192.168.1.254. That's my gateway. Space, I need the mask. 255.255.255.0. That's a 24-bit mask. And enter. All interfaces on the router are off. Let me show you. Do, because I'm going to type a command that you normally do in privilege mode. So I have to do it here with the do. Do show IP. You see how I'm not writing out the whole word. Do show IP interface. I'm not typing out the whole word. Do show IP interface brief. I want a summary. And the G00, let me make this a little wider, make it look prettier. You can see here the G00, that's where I put the IP address. Look, they're all down. All of them are down. They're administratively down. That means nobody ever turned it on. So now I'm going to do a no shut because I'm still inside the interface. I already put the IP address, and I'm going to do no shut. Hold on. Out of curiosity, I've seen when run command and switches, they show me PKI certificate. It's something we add. Yeah, that's not normal. If you're doing PKI infrastructure, definitely that will be something that you did additional for security purposes. So yeah, certificates are something that's not by default. That's not something you do on a normal basis. That's just based on security. All right, so yeah, definitely. That's something you have to add. All right, so now let's take a look at that same command. Up arrow key. I don't have to type it again. Now you can see that when I did a no shut, which means it turned it on. I don't want it to be shut. I want it to be no shut. So I negated that command. So it turned interface up. So no shut turns on interfaces. Awesome. But again, we need to verify that this is working. So we see that this is here, show IP and brief, that is up. That's great. But do we really have connectivity to it? All right. I'm going to ping. Now, this is the first time I'm going to ping. Let's see if the packet tracer wants to play nice. And it will show us the ARP as well. And that's how you do it. Ping. Oh, let's do it from IP config. Hit enter. That tells you your IP address, your server mask, and the gateway. This is what I want to ping right here. Ping 192.168.1.254. Hit enter, and it is playing nice. So you can see that we want to ping. That's a protocol used for pinging, ICMP, but it's the first time we do it, so we have to ARP, the address resolution protocol. You need to know the MAC address of this interface in order to continue. Remember, day one, I think it was, or day two, we talked about that, where well, for networking, you need 5 things. A source and destination layer 2, source and destination layer 3, and a port number. Okay, so the source MAC address is your computer. The destination MAC address is this interface right here. MAC addresses don't leave their segments. Okay, so you need that MAC address, which you don't know right now, all right, in order to complete this packet. Destination IP address, well, that's it right here. That's what I'm pinging. All right, that's what I need. So I know that. And there's really no port in ICMP. If you're creating some sort of filter that you want to block that or permit that, whatever the case may be, if using the protocol TCP, you use 7. But normally ICMP, you don't. This doesn't have a port. Let's play. There goes the ARP. Come on. There you go. You see, it's still all ARP. It's still all ARP. Because you first need all the information before you can actually ping. And now you can see right here, you're about to ping. And now you can ping. That's an echo request, and you get back an echo reply. There you go. That's exactly what happens. So you can do this in the packet tracer, but when you go here to the command prompt, let me maximize this window. You see what it did, right? A reply. It did that reply, and we take this for granted when we're doing it, because we just go up here, ping. Oh yeah, I got a reply. We really don't know what's going on, right? Because this is just right here. Well, what if we have, like we do on the internet? You know, we're trying to ping Yahoo or anything like that. Think about what's going on. Let me go here, my command prompt. I hope you can see it. Let's do cd ls. All right, and this just ping google.com. Now it's all IPv6 what you're looking at, and we take this for granted. But you imagine how many things you had to go through to get to a Google server or DNS server to give me back that information? That's I mean, it's 4 replies, but it goes far. And if you were to do a trace, meaning you're tracing the route of where it took, it's up to 30 hops that it can do. All right, so we take a lot of things for granted, but that's what's happening in Ethernet, right? IPv4. That's what's happening. You have that broadcast. You have that ARP broadcast. But once you do it once, that's it. All right, so now we can get here, but now we need to go across. All right, so we need to configure this interface. Now let's talk a little bit about this. Nobody uses serial interfaces anymore. And you can see that there's a symbol there. Let me exit out of here. See, exit. Control Z takes me back there. Just so there's not a whole bunch of lines in front of you to confuse you. All right. So the serial interface, right? We used to use a long time ago, and that's during the days of, you know, if you have T1s, you had dial-up, things of that. Very rare or legacy devices still use serial. And when you see that, that means that's a data communications equipment side of the cable, okay? And in order for you to be able to make it work, there's something called a clock rate. And this is at layer 2, all right? A clock rate, which synchronizes the speed of what your provider told you to put, okay? So in here, we will go to config T, and we go into that serial interface S0/0/0. It used to be S0. Why now? What's up with all these other zeros? The first 0, because it was fixed routers. Fixed. It came already welded in there, an interface. And the S0 was always the DCE side, the data communications equipment side. Then they had another 0. Okay, so this is now the slot. It's not just port, now it's a slot and port. And now they have 3 zeros. Why 3 zeros? Because now it's router, slot, and port. Okay, that's what that means. So you hit enter, but you can put an IP address, and we didn't put really a network in between these two. Let's put one. Let's copy this, Control C, Control V. Click in here. I'm going to select the whole thing. 10.1.1.4. That's the network with a 30. What does that mean? Well, it's a class A address, but it's a subnetted class A address. This is in the last octet, 6 bits in, which means I increment by 4. That's why you see the 4 network there. So that means 1 less 4 is 3, which is the broadcast number. 3 plus 4 is 7. So what's in between 4 and 7? 5 and 6. That's how you need to do subnetting. When you're doing this, you need to be looking at this and you already know what it is. If this is your first time, that's fine. We're going to be doing subnetting, so don't worry. All right, we come in here. I'm going to put the IP address. IP address 10.1.1.5, 2.5.2.5.2.5. A 30-bit mask. You want to type? Anybody want to take a good Guess at what that mask is. A 30-bit mask is what in dotted decimal? If you have 6 bits on, is that a 255? Is that a 240? Is that a 248? Is that a 252? What's that last one? Very good. Thank you, Christian. Okay, 252. There you go. Now, you need to put in a clock rate. In the clock rate, there's many clock rates. Normally, back in the day, because of the speeds, it was either 56,000 or 64,000. Here, it doesn't make a difference. Okay, it already has this as default, I believe. No, really. What does it have? Yeah, I think that's the default that it has. I'm going to put this. All right. 1, 2, 3, 1, 2, 3. That's everybody's paycheck, right? That's what we all get paid. And then now I'll do the no shots. But I want to show you this. Now I said it went down. Why didn't it come up? Let's take a look at that. I'm going to do a WR to copy, so I don't lose any of the information. All right. And I'm going to look at the show IP int brief. And I'm going to make it wider. Can I set DTE and DC device on fast Ethernet? No. A fast Ethernet interface, you just straight put the IP address on there. There's no clocking on the fast Ethernet interfaces. No clocking whatsoever. Okay? It's only on serials. Only on serials. All right. Now you can see here that this one didn't come up. It says down, down. That's a layer 1 issue. That's a physical layer issue. Why is that? Why is it down, down? Because I haven't configured this side yet. When this comes up, that'll come up. But that's why it's down, down. Layer 1 issue. Okay? So let's go back in here. But let's take a look at it. I want you to see it. So there's a command. Show controllers S, be specific, not just show controllers, S0/0/0, because if not, if you have a router with 20 interfaces and you do show controllers hit enter, you're gonna look at everything on that, on every interface. So hardware information, what am I looking for here? That right there, DCE, clock rate 4 million. Right, so that one's the one that needs to have a clock rate. So if you don't have it, you see this, and you don't have a clock rate, that's the problem. Now you may be asking, hey Laz, man, well, what if I'm putting it in a real router and I have to plug in an actual serial cable to one of these ports? And these, just so you know, they're called smart serials. Why are they smart? I don't know, but that's what they're called. How do you know which one to plug it into? Luckily, since they're smart, the cable is the one that decides who's DCE or DTE. So wherever you put a DCE on there, that interface is going to need the clock rate. It's the cable that decides, not the interface. All right. Before, on the fixed routers, it was the interface. Now it's the cables. But you can choose whichever one you want. DCE and then DTE. But again, nobody does that, but that's how the way you would do it. Okay. So again, we can't continue because that's it. We've done what we needed to do here, but we need to now configure this side. So let's start from the bottom up instead of going across and down. Now we're in this PC, and I want to see it in the chat. The serial cables are still in use nowadays. Very few networks. I know, let's say like, what's this friggin' company? There's one company, very huge company. I forgot the name right now. L3 Harris. L3 Harris has legacy equipment that they cannot upgrade due to applications and what have you. So they have old hardware. They still use serial cables. They still use frame relay. And frame relay is just a protocol like MPLS for wide area networks. All right. That's a type of packet switching technology to send information across a wide area network. So certain companies are restricted by their legacy equipment and they'll use serial cables. If not, everything is Ethernet, whether it be fiber or using shielded twisted pair. It's Ethernet. It's Ethernet, not serial, not serial. If you're working in a company using serial, you need to update them. So now we go to the PC. On the other side, desktop. Now we come here, 192.168.2.0. We still have the same mask that we did over there. Instead of being 1.0, it's 2.0. Okay. 192.168.2.1. 254 IP addresses, 1 through 254. I always use the first one for my host. Tab, default mask for 24. What's my gateway? The last available IP address. That's it. You want to verify that? No problem. You come to the command prompt, IP config. And you get to see that. All right. And here is where you see also, here is IPv6 link local address because it exists on every interface. All right. But here's your loopback for IPv6. Not your loopback. I'm sorry. That's all zeros. Here is your IP address, IPv4. There's your mask, and there's your gateway. Okay. Now there is another command. I up arrow and do. Oh, here you guys actually space and do all. And you can see a lot more information. Here's the physical address, meaning the MAC address, right, of the actual client. You see more information like DHCP, right? This is something that's going to be interesting for you to know for later on, all right, when you're doing IPv6. But definitely on your interface, you need this a layer 2, and this is your layer 3 right here. All right, so we got that squared away. Let's go over here to the router now. And play around with the packet tracer and move it around to meet, so you can have the work area and you can still see what you're doing. Okay. Give yourself space to work. Again, this is a router. It kicked me out. All right. So say no. I'm going to say enable. Well, I don't think I did anything on this one yet. So config T, right? Went from user mode to privilege mode to global configuration mode. Now we're going to put in the host name. H, and right here is the only thing that exists here. So if I just type H and I hit tab, that's what it's going to put. That's not the case. That's not the case on your routers, but you can get away with that here. Host name, this is R2, router 2. We hit enter. Now you're on R2 global configuration mode, right? Now we can type in all the same things we did before. I like to do these especially IP or no IP domain hyphen lookup. And I immediately go to line count 0 and I type this, login, synchronous, right? Because I know I'm going to make typos and I don't want to get interrupted. But since I'm here, right, let's do the other commands that are supposed to be for here. So we're going to say login local, right? Because we're going to create a username here as well. Okay. And we're going to say the exec hyphen timeout, 10 minutes and 45 seconds. All right. What else did we type in here? Nothing in there, right? Let me take a look at my little things. Yeah, that's it. That's it. Login local, login synchronous. And yeah, that's it. So now we're going to go, let's finish up the lines. Line VTY. And again, this is not set in stone. This notepad that I gave you, or hopefully you can download, that gives you these commands right here. Okay. I mean, it gives you a little bit more, but all these commands, you can literally copy paste it into the router, right? Starting from up here, from the enable, right? But you need to know. So I can type these commands that I'm doing in Notepad because I know where I'm at, where I'm navigating through, and then and start in user mode, and then it'll go ahead and do it for me. Okay, that's my automation. Line VTY 0 space 15. Login local. Oh, we're going to give it a password. That's right. I'm not going to do that. Login local. Login synchronous. And then exec hyphen timeout. 10 minutes, 45 seconds. Cool. I want to create a banner. I can exit now. I can create a banner. I'm going to start with the MOTD, message of the day. And I'm going to use the money sign. And this one will stay out. And then I'm going to end it with the money sign. Okay? It's whatever's in between those two delimiting characters that's going to pop up. All right? And we need to do enable, plain text, password, Cisco. All right? We got to start securing the router. Enable, secret, student. And then we're going to go and say service, password, hyphen encryption to encrypt all the passwords. And they're in plain text. All right. And all right. And now we're going to go into the IPs. Interface, S0/0/1, enter. IP address is the other side of that address. 10.1.1 at 6, 255, 255, 252. And here is a DT, data terminating equipment, no shut. And let's take a look at it. Do show controllers S0/0/1. Oops. And you can see that it says DT transmit and receive. Somebody yesterday asked a question about TRD2, and I was going crazy. And I was like, oh, the pinouts. That's just a transmit and receive pin. All right. So if you're plugging it into a device that's enabled automatically, all right, you don't know which ones to use, because depending on which IEEE standard you're using, whether it be 10 base T, 100 base T, or whatever, some of those the blue and white cables are not used. So that's what the 2+, the TG or the TRG or TGR2, I wrote it down. TRD2. That's what that meant. All right, but they're transmit and receive. So this doesn't need to do the clock. It detects the clock. It detects the synchronization. And just so you know, all routers by default are DTE. Once we start using Ethernet, that's a different story. That doesn't come into play at all. But if you're using serial, all routers are by default DTE. The clocking is going to come from your provider. They will tell you in your devices that are using the serial what clocking you should be using as well to match up. All right. So we're in router 2. What I did was to get out of that, let's say Control C. It's a break command. Control C. And I'm still inside that prompt. So I'm going to make sure that I get out of that prompt because I want to go to the G00 interface, G0/0, and I type IP address 192.168.2.254, 255.205.205.0, and then no shut. Oop. There we go. And then I'll do it the long way. I'm going to type end. I'll do copy, run start, copy what's in RAM to NVRAM. That's the file that is going to be saved at. Okay. And now I want to maximize and just look through my configuration. Show run or show start. All right. So you can see that we turned this on. We have our host name. There's our student password. There's our Cisco password that's being encrypted by this. There's our no IP domain -lookup. I didn't do the history and I didn't do the clock. There's the interfaces right there. There's that interface. There's that interface. All right. There's the banner. There's the line count 0, XML, login synchronous, login local. And the same thing for the VTY. But you see how it separates this? Because I put the maximum number of lines. These are your default telnet lines. And then these are your additional telnet lines. And I'll always do that. Okay? I'll always do that. All right, cool. So we look at it. Now, we have green lights. Beautiful. We didn't verify. Let's verify. We didn't verify. Let's ping our gateway. Let's ping that address right there. Ping 192.168.2.254. And we get a reply. Beautiful. All right. And let's see if this router can ping this router. We didn't check that either, did we? Ping 10.101.1. I'm pinging the IP address on this interface right here. And one of the buttons you're going to use quite a bit is this one right here. So you can just hurry up. Why am I not pinging there? All right. Time to troubleshoot. So we can't ping. We got a bunch of dots, request timeout. We didn't get there. So let's take a see what's happening. Show IP int brief. Take a look at that. Here's 10116 under the 0001. It says that it's up. Okay. Oh, I know why. I pinged the wrong IP address. Up arrow. It's IP address 5, not 1. And now I can ping. Just realize that, right? So, but again, you will do your troubleshooting steps to figure out, why did I ping? This is up. And then when I saw 6, I'm like, oh, okay, the other one must be 5, because you need to know your subnetting. All right, you need to know what networks you're working on. So this IP address will be in the 0 network. We're in the 4 network. So we can ping from here to here. We can ping from here to here, and we can ping from here to here. But this is the CLI configuration, and the same things you can do in your switch. So let's go to just this switch alone. All right, and let's just take a look at it, because eventually we want to get all the way across, don't we? So let's come in here, and we can do the exact same commands that we did on the router, you can do in this switch. So enable, config T, T, host name, SW1, same rules apply, no spaces, okay? Hyphens or underscores. And now we're going to do enable. Can I route VLAN? Yes, you can. Yes, you can. And we're now working on something called VLAN 1, and it doesn't have an IP address, but we're going to be putting one in there, right, for management purposes. But yes, you can route, but not in these switches. These switches cannot. These switches cannot. These are layer 2 only switches. There is no routing here. Only you have layer 3 switches. All right, enable password, Cisco, enable secret student, service, password, hyphen encryption. I live for the tab, and you can do it in your CCNA. All right, and then we didn't do the clock. I guess if you want to do the clock, we could. Let's just do it on this side. So clock, I exited till I got to privilege mode. Clock set, question mark, time, 11:53. For those of you that came in here a little later, we're not going to stop at 12:30. We're going to continue to 1, because yesterday I stopped early for some reason. My brain died or something. Okay. So we're going to continue forwards. All right. Then we got the day of the month, which is 8, I believe. The actual month, which is December. And the year, 2025. And then we go to config T, global configuration. All right. And now we're going to type the time zone, right? Clock. Time zone. That's Thai for Thailand. And then -7, because it didn't take anything else. All right. To do that. So we have the clock in there. But again, here in this layer 2 switch, it's pretty much the same thing that you just did on the router, right? We got the line con 0 as well. Line con, I think we did that, didn't we? Did we go in there? No, we didn't do that. So let's do line con 0, or let's first do this one. No IP domain hyphen lookup, definitely. I don't know why I didn't type that. Line con 0, login synchronous, same thing. Log in, 2 different G's, log in local, we create a username, exec hyphen timeout, 10 minutes, 45 seconds. Go into the line VTY 0:15, same old. Log in synchronous, log in local, exec hyphen timeout, 10 minutes, 45 seconds. So you can do that on every line, right? Putting those exec timeouts, the lines are the same thing. Same thing we did on the router. We just did that. All right. But let's create a username here as well. Username, let's use the same thing. LDS, privilege, 15, password, 0 plain text because service password hyphen encryption is doing it for me, and I'm not going to type an encrypted password already. So what do we use? I think we use Cisco. All right, do that. But now this is a switch. Let's save it. So we're going to end. I'm just going to do WR. You don't forget that you can do that. Or you could have done do WR. All right. Or copy, run, start. Let's take a look at this real quick. So if we go show run, there's the stuff that you saw in the router before. No service hyphen for encryption, the host name, the passwords right here, tie, IP domain lookup, the username. But now we got a whole bunch of interfaces. It talks about spanning tree. We're not worried about that right now. Okay. But here's your console and all that. But in the switch, in the routers, we put IP addresses on their interfaces. In this layer 2 switch, we cannot put an IP address on the actual interface. We cannot. I'll prove it to you. Do you need to configure full duplex or by default or go auto? Normally, the switches come already dynamic auto or they're set to full. But if you want to set it to full, it's up to you. You definitely with dynamic auto, and that's just the way when you plug in cables, it knows what to do. But you're doing certain configurations. If the ports themselves, meaning interface F01, F02, F03, they're set to auto. An example is you can't create a VLAN, or you can't assign a VLAN to a port that's dynamic auto. You cannot create switch port security if you're in dynamic auto either. So it has to be a static port. So I would set the duplex. Me personally, I would set it to full, so you can get the benefit. Because again, cabling yesterday, if you're gonna buy a Cat 6 gig cable, you're not gonna buy a switch that's only for Cat 5e. That makes no sense. You're not gonna buy a NIC card that's for Cat 5. You buy a Cat 6 NIC card for your computers or whatever. You buy devices that have Cat 6 NIC cards. You're going to use Cat 6 cable. You're going to buy Cat 6 switches, meaning switches that support gigabit for real. All right. And the same thing goes for the routers. You got to have consistency in your network. If you're mixing and matching different things, you're going to run into issues. All right. So let me show you here. Let me prove to you that interface F0/1, you can't put an IP address. IP address 192.168.1.253, 255.255.255.255.0. You can't put an IP address on a layer 2 switch interface. Cannot. But you can put it in the VLAN. Let's talk about a little bit about that. Let's look at it though. Show VLAN brief. Let's talk about this. By default, this is called the native VLAN, the administrative VLAN, the management VLAN, whatever, the default VLAN, okay? So by default, we're all part of this VLAN. That creates one broadcast domain. What does that mean? If you're in a switch like we are, let's say you have let's say you have, like the school that I worked at many months ago, brick and mortar, they had 32 48 port switches. On the student side, we were all part of the same VLAN. By default, layer 2 switches create one broadcast domain. That means you're all in the same room. So everybody's talking, everybody hears that noise. Well, that's a problem. But we'll get into creating more VLANs later on. But just know, in your company, all right, if you don't have additional VLANs created, that's going to cause an issue. That's going to slow down your network. It will slow it down. All right. Our purpose as engineers, network engineers, is to increase the efficiency and security of our network And by efficiency at a layer, using layer 2 switches, if we're talking about VLANs, we need to create more VLAN. That creates more broadcast domains that decrease the amount of broadcast and the amount of noise. I don't know if you ever heard this saying before. What happens in Vegas stays in Vegas. What happens in a VLAN stays in a VLAN. So if you're in a VLAN, you're in a room, and you're all talking amongst each other, nobody else knows what you're talking about. They don't hear that noise. They can't get to you based on security settings, but they don't hear the noise because you're inside your room. You're talking about networking, and that's it. The other room is talking about security. The other room is talking about cars, whatever the case may be. We don't hear each other's noise. So that's why you want to create more VLANs, because you're creating more broadcast domains, which will decrease the broadcast. All right. So, but what you can do though, you need to be able to manage that. There was a time in the beginning before we would have unmanaged switches, and we could not manage it. We cannot go inside the switches to do any kind of management. So now that's not the issue. It's been like that for a while now. But so what you do is, if you have a layer 2 switch, then you can't do routing, you can't put IP addresses on the interfaces. You do it on the VLAN. So on VLAN 1 config, we have to go to global configuration, and then we can say interface VLAN 1. Now we can put the IP address 192.168. I'm sorry. IP address 192.168.2.253, 255.255.205.0. Now, why did I choose 253? My gateway is 254. That's the router. That's my doorway to the outside. I'm just putting an IP address in here, so I'm able to manage it. That's it. So I can able to go inside the switch and be able to do things to it. All right. And then VLAN 1, that's there by default. I didn't create that. It came that way. That's why that's the native VLAN. It's the only VLAN that you have to turn on. By default, it's off. Do show IP int brief. So we can take a look at, there's a lot of interfaces here. You can see that fast Ethernet 01 is up. We have a computer plugged in there. All right. We hit space bar. Look at the VLAN. I get an IP address, but I haven't turned it on yet. It is down, 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 down. And this is the one that's going towards the router. Okay. So again, we cannot assign an IP address on this interface. So I need to no shut this VLAN interface. That's where I'm at right now. See, it says VLAN 1 change state to up arrow, your keyboard, space, and now it's up. So now, I don't know, I think we configured the telnet lines. I'm pretty sure we did. Let's take a look at our configuration again. Keyboard command, Control Z, right? Let's do a show run again. So this should be Cisco LDS, right? Username, but I want to go all the way down to my telnet lines, and they are configured. All right, and I'm using login local. Beautiful. Let's test this theory out. Let's go from this PC. Let's get inside this switch. So I'm going to telnet into that switch, hopefully. Doesn't look like it's going to happen. Nope. Connection timed out, remote host not responding. Really? So here's our line VTYs, exact timeout, 10:45, login synchronous, login local. Let's put in a password there, even though you don't have to, but I'll try anything, Packet Tracer. And that's what I like about the Packet Tracer, that it has certain quirks and it makes you troubleshoot 0 space 15. Let's just put in password. Oh, I know. Okay. And okay. Mango, right? But one thing that I didn't do, which you didn't have to do before, but now you do. Take note of this command. It's in your notepad, in the notepad. Transport input. So what are you allowing? What type of, are you allowing SSH? Are you allowing telnet? Are you allowing all? None, right? So for lab purposes, I say all, right? Real world purposes, obviously, you would just pick SSH or whatever security protocol you're using, right? To be able to get in, right? So let's save that. Let's try it again. I think the cause was this, not that I didn't have a password. Okay, so let's try it again. Dude, seriously? That's okay. I don't need the gateway. I mean, the same, because there's another command. If you're remote, which we're not, we're part of that VLAN. All right, because let's test something out. Let's start from scratch. Let's troubleshoot. Why can't we get in there? All right, so let's ping it. Ping 192.168.1.253. You see, it's not letting me ping that particular IP address. That's interesting. IP config. Well, not even that. Let me ping the gateway. I can ping the gateway. So I do have the right IP address on my computer. I can do an IP config, right? And I can see, yeah, 1.1 to, okay, all right. I can ping the gateway, but for some reason, it's not letting me in here. All right. So at all, MyB2I0, space 15, password mango, transport input, all. I mean, I'm allowing SSH or telnet to get in. I don't see that. The only thing that I can think of, which you don't really need to do unless you're trying to, from a different subnet, remote subnet, trying to get in, IP default hyphen gateway. What's the gateway for this switch? It's that router, right? The G00 192.168.1.254. That's the gateway. Other than that, you're okay. There should be no other issue other than that. Now, let's try something. Let's go to the router. Again, troubleshooting. Let's go to the router. That's why navigation is important. Now, username is LDS. I believe I think it's Cisco or students. Okay, Cisco. Let's ping 192.168.1.253. So again, I'm going to do the fast forward button. I'm just going to click it once. So even from here and here, it's not letting me in. It's not letting me in at all. So let's run through our configurations here very closely. I'm going to copy it again. And we'll do a show start this time to look at NVRAM. So we got the enable secret. I'm starting from here and I'm going down. So enable secret, enable password, the clock, no IP domain. Here's a username. I don't even get to that point. All right, here are your interfaces. Int VLAN 1. I can try to no-show that again, have a default gateway. 192. Oh, there it is. Right there in my face. Instead of 1253, I put 253. 2253. So that's the issue. I'm in this subnet and I put the wrong IP address, the wrong subnet. So that right there, that's why you need to look at it and be aware of what you're doing. So config T, gotta go back to global, interface, VLAN 1, right? And luckily for us with IPv4, if I put the right IP address, it'll overwrite what's there. So I'm gonna say IP address 192.168.1.253, 255.255.255.0, enter, copy it, and I'm going to do it right from here, do WR, and I'm going to look at it again from right here, do show start, go all the way to the bottom, space, 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 meaning space bar, okay? And there's the IP address, 1.253. All right, let's see if that was the issue. I don't think there's any other issues. That's the issue. All borrowing, telnet. And now, LDS, enter. It should be, I think Cisco, CISCO. And now I'm inside the switch because you're not gonna walk over to your switches and log. I gotta go to the server room. I gotta log into the switch. You're not gonna do that. If you're managing a very large enterprise, you'll be SSHing or telnetting into this particular device in order for you to manage it. Now, what happened right there was what you need to try and avoid. You always go for the easiest thing, which was, is there an IP address? Did I type the right IP address? But we're so used to, oh my God, the gateway. Did I turn on the protocol? So you're going for the hardest things first, where really when you're troubleshooting, you look at the easy stuff first. So if I could have picked my router, that was fine. I should have known then and there, there's somebody has a wrong IP address. So I should have just done show IP and brief from the get-go, seeing that there was a wrong IP address and change it. So go for the easiest things first. Don't try, like if your sound wasn't working, it was because it was muted. But we try to look at the drivers and what's going on, going into deeper things that we don't need to be going into. So we can get into it. Now we can exit out of it. And now let's see if we can get inside the router. So we're going to telnet, because we also turn that on, 192.168.1.254. Username, LBS, should be Cisco. And now we're in the router. So that is what telnetting is. It's a terminal emulation. You go in there, and now you can do show run. Same thing on the switch. Show run, take a look at your configurations, all that. That is the reality. And when you're in taking the test, if they ask you questions on telnet, it'll be very, very basic. What port number does it use, which is port 23 for telnet, port 22 for SSH. Okay, port 22 for SSH. So this is really, really important to be able to do. Let me exit. But what if I want to go from a router to the other router? What about that? Now here, let's take a look at something real quick. On this router, we're in privilege mode. Let's do show commands. Let's just look at our configuration real quick. Let's do a show start. Here's a username. LDS has privileges, but you know what? I want to create another username. I want to test something out. So how do I go? I got to go to config T, global configuration. Let's create a username, Susie, and hit enter. That's it. That's all I'm typing, Susie. And I'm going to save that, do WR. All right. And I know that my telnet lines are in there and they're set to use the local username and password, right? And let's see if this works here. Show, run, these are pipe commands. Pipe, the section that just shows me the lines. So I'm take a look at the whole thing, right? In a production router, this is what you do. You do not go to a production router and type show run. You can actually crash it, okay? Don't do that. Oh, you'll be browsing forever, okay? So now here I have my lines. Here's my line con 0. Here's my line aux, which I haven't done anything. Here's my VTY lines, which are my virtual terminal lines, which is my telnet and SSH lines. All right, and it's using login local. Awesome. So I just wanted to verify that. So now I'm going to go into this router, since I have communications with, and I'm going to telnet from this router. Oh, look, it kicked me out. 10 minutes, 45 seconds. It kicks me out. Okay, username, LDS, in caps, case sensitive. And then, what is it? Cisco. Oh, really? All right. If you forget, and we're going to use this as an example for something else. If you forget, remember, config, interface, CLI, and now you're in. So exit, exit. Now you're in privilege mode. All right. I'm going to telnet into router 1. Now, I can type the word telnet and put the IP address. You don't have to. This is the IP address of that interface. I'm going to use Susie. Oh, Susie don't got a password. I'm in anyway. But where am I in? I'm in user mode. But remember I told you earlier that you can create a user account, username, whoever, hit enter. Now I'm telling the telnet lines log in local to use the local username and password, but Susie doesn't have a password. So I just hit enter. That's a blank password. And with all these things that are going on today, with all these different hacks, you cannot allow this, because if a hacker gets access even to this mode, which is user mode, even if they get there, they can get everywhere else. So you need to make sure that everybody has a certain privilege and a certain password, okay, in order to get in. So Susie doesn't know my secret password, so she can't get in. All right, so she's stuck right there. But I was able to anyway get to that router, all right, by a blank password. I wanted to show you that. All right, so I'm going to hit enter a couple times. That's going to time out, no good. I'm going to exit out of here, and I'm out of router 1. All right, but just to prove the point, they got to be very careful, and you need to secure your router. So when you're doing your configurations, part of this, I call this basic housekeeping. Basic housekeeping, this right here. And we haven't done SSH. All we've done is, so far, we've just done telnet, okay? We haven't done SSH yet. Just waiting on that. Now, we had an issue over here in this router, right? I'm going to exit. I can't get in. I forgot the password. I don't know what it is. I can't do this. So there's something called bypassing NVRAM. Remember the components that I told you, the RAM, NVRAM, and then you have your ROM and flash, which is where your iOS sits. So when the router boots up, it looks for that configuration file. If it sees there, it loads it. So I don't want that. All right, I forgot my password. I need now. You better not do this during working hours, obviously, but this is something that they teach you that you need to know. All right, so what we're going to do here, we're going to emulate it as best as we can. Obviously, there's no tabs in real routers. You turn them off and turn them back on. So I'm going to come here, put a config, and I pray, hold on. When I go back over here, I want to make sure that's saved. All right, so I can't get in. So I'm going to come to the router. I'm going to turn it off. Let me zoom in. I'm going to turn off the router. When I turn it on, I'm going to quickly go to the CLI. I'm going to do a break command, Control C. Okay, so I'm going to turn it on. CLI, Control C. So what did I do there? You see what it was trying to do is to decompress, because the operating system of these routers, they're compressed in flash. When it loads it into RAM, they get decompressed. Okay, so I prevented the boot up process by doing Control C. And there's many break commands. The other one you should be aware of, besides, well, there's two others, but you can do Control C, Control pause break key, Control pause break key, or Control Shift 6. Control Shift 6. Okay, and that it works as well when you're on the router. If you type something, you didn't do no IP domain lookup, and it's just looking for something that doesn't exist, or you just want to break out of that command, let's say like a debug or something like that, looking behind the scenes, Control pause break. Control Shift 6. Control Shift 6 works. Okay. Can we telnet or SSH the host name as well? We can. We can do that as well, but we need to set that up. And there's two ways of setting that up: using DNS, which I don't recommend, or static host tables. All right. But right now we need to find out how to get into this router, because we forgot. So Pay close attention to this. This can help you or this can break you. All right, this could be a resume writing command. So here you're in ROM monitor mode. You're in ROMing, okay? And if you type in lowercase help, there's a limited amount of commands you can type in there. What we're gonna type is this, config. We need to change the register in our router that has hex numbers, and the hex numbers tells it how to boot up, what to do on boot up. So the default is 0x2102, 0x2102. That tells the router that on boot up, please look at the startup configuration file, and if you find any configurations, load them into RAM. What I'm going to do, I'm going to type configure register 0x2142, which says, don't look at enemy RAM, just let me in the router because I don't know the password. Okay, so I'm going to say config 0x2142, and now I need to reload. I think it's initialized. I think it's reset. I'm sorry, now it's reset. Used to be initialized, now it's reset. Okay, so now it's taking the iOS and loading it into RAM. It's not going to look at NVRAM, so it's not going to show any startup configuration. So I'm going to be there. Do you want to be in the wizard? This is setup mode. No, I do not. But just don't go in here and say, oh, I'm just going to change my password. I'm going to recopy it back. If you do that, okay, you are copying just to change. Because if you were to look at show run right now, there's nothing there. And all you do is change the password, you save it, and then you change back to 2102. All you just did was override that same file that you're saving to. So the first thing that you need to do after you do this, all right, is config T. Oh, I'm sorry. You don't need to do it from there. You want to copy what's in the start and do the opposite. You want to copy it to the run. You want to copy what's in your hard drive, in your enemy RAM, and copy it to your RAM. Is that the file you want to go to? Yeah, that's exactly it. I'm going to file it to the RAM. All right. So now if you look, show run, now we got stuff up there. Oh, we're safe, right? And there's IP addresses and all that. So what do we want to do? We want to change the password, right? Config T. All right, and then we're going to say, what was it? It was the enable, right? Enable, let's just do them all again. No, just enable once. Enable, password, Cisco. Enable, secret. Oh, it was student, wasn't it? Student, okay. Enable secret student, okay? Now you can save this, now. So you can do end. You made the change you wanted. You copied everything up first, made the change you wanted. Copy, run, start. Completely opposite, isn't it? But now you're copying everything that's in RAM, which is all the configurations, back to your start config file. What is IPsec? Cisco Express Forwarding, and what that does, it actually speeds up the process when it's looking at to send information across. So you use IPsec together with MPLS, so they work together. So it just speeds up the process of sending packets across the network. That's what that is. Normally, IPsec is normally on, not on the packet tracer, but there's also an IPv6 Ceph as well, which you need to turn on as well to make things go quicker. That's all it is. That's all it is. But normally use that in conjunction with MPLS. So one of the things you want to look at when you do this, and if you're working, you see something funny, or you want to check, you're welcome, show version. Okay. What are we looking at for? Oh, well, the show version gives you a whole bunch of information. Check this out. The operating system, the iOS, okay, the version of the operating, but that's not really the version I'm looking for. Here's your flash. This is your actual, because our operating system, the routers are specific to their series of router. Okay, here's the iOS right there, some other information. But what I'm looking for is none of this. You can see this is a licensing IP-based K9. This is what I'm looking for right here. The configuration register, which is what we changed, is set to 0x2142. Now you can work perfectly fine like this. If there's a brownout and this you leave it like this, when your router boots back up, it's going to ignore the configuration and it's not going to load any. So what does that mean for you at your company? Because real world example, come back on Monday. No, you're all parts of VLANs. You have email servers, web servers, file servers. No connectivity to anything. You can't work. You can't go anywhere because your routers don't have the configuration. First thing you want to look at, do a show version and see what that is. So if you want to change that and you're already in the router, you don't have to go to Ramen where we're at. Ramen is a dark, dirty dungeon. You don't want to be there if you don't have to. Okay? So config T, and you do config register. See, now we can type the whole thing, not confreg or confreg, right? Weird. Config register, but now we want to change it back. 0x2102. We want to change it back. Now we want to tell it to, okay, if you reload, I want you to look at NVRAM and load whatever configuration is there. Okay? We're going to save that, do WR, or you can go back to privilege mode and type copy run start. And let's do a do show version from here. All right, and look what it says. It still says that you're here, you're working right now here, but if it reloads again, it will change to 2102. If it says that, I'm okay, that's fine, no problem. All right, because if there's a brownout or a power outage, this time it will change it to 2102, and then it will look at NVRAM and load up whatever's in the startup config file, all right, and load it up onto RAM. Oh, okay, we're cool now. We can go ahead and we can live with that. We can live with that because that is a reality of thing. A reality of thing. All right, so you can see the navigation more or less, and you can see the configurations that you need to be aware of just to be able to get to one place to the next, right? But we're still not getting across. That's not happening yet. Now, a question was asked, which is a good question. All right. Oh, by the way, now that I see the little red lights, one of the things that happens on here is that your interfaces are down. Show IP in brief. Show IP in brief. It's a summary. See, it says down. Should I come back in here? Forgot about that. Come back into each interface. Well, the interfaces have IP addresses. Interface G00. No shut. Turn it on. And then the other one is the serial. Up an arrow. S0/0/1. No shut. Okay. Now, the question that was asked, and we can do it from right here. If you can use, you can telnet through name. Sure, you can, but you need to set that up. It's not a big deal. Now, I want you to think for a minute. If I do it through DNS, what is DNS? DNS is the domain name service. It resolves IP addresses, or it resolves names like Cisco.com or networkkings.com or whatever website you're going to. It has to go through a DNS server. Says Cisco.com. Oh, Cisco.com is this IP address, and then it takes you there. It resolves that. Computers don't know names. Computers know IPs. They work with IPs. Okay, so to put that in the middle of a router, I don't like it. I got to get a DNS server. Okay, to actually, because if you set it up here, you need to point it to a DNS server. So you're telling me you want to go down to a DNS server and then come back up and then go across? No, I'm going to create a static host table. I'm going to say IP host R1 is associated with 10.1.1.5, and it's also associated with 192.168.1.254. That's a static host table. So instead of me pinging or telnetting or whatever through a IP address, I can do it through a name, but it's already here. It's already here. It doesn't have to look for a DNS server. I'm going to copy that. I'm going to Control Z to get to privilege mode, and I'm going to ping something simple. 10.1.1. I mean, not really. 10.1.1 R1, and I can ping. So you can ping by name too. So static host tables in a large network, obviously, it's time consuming. You're not going to do that. It's a lot. It's a lot of IP addresses. You can put about up to, I believe, it's 8 IP addresses per host they can relate to. In case one's down, you can go another way. But a lot of people do use DNS, and that means at that point that you would be doing this. I don't like that. I'll show you. You saw how simple that was, right? Saw how simple that was. We're just creating a host table, not a big deal, right? Just IP host, the name, and then the IP address is associated with that name. If you do want to use DNS, IP, remember how we turned it off? IP domain lookup, we have to turn it on. Then do IP domain hyphen name, and whatever the domain name is, let's call it cisco.com. All right. And then you point it to the actual DNS server. Where's it at? Where's it at? It should be local, okay? Or unless you have a domain or DNS server out there on the internet that you want to use. Name hyphen server. And let's just give it, we're in router 2, 192.168.2.1. So that you will need to go to that server that has that IP address and create those records. But that's something else. But this is how you would set this up in the router. But again, I normally turn this off. But for me, that's fine because I don't do this. Because I don't like it. So I just basically just turn that off. No IP domain hyphen lookup. Because I type so many typos, and regardless, if I leave that on and I point it to a DNS server, it's still going to take that typo and go to the DNS server and then come back and say, yeah, no, that was wrong. I don't want that traffic. So I do host table. I can understand in a very large network where that will come in handy. Okay, but that's another thing. Now, before I want to get connectivity across before I show you SSH. Now, this is not routing yet or anything like that, but we've seen a lot of navigation to the switch and to the routers. But we need to be able to get to the other side because right now we can't. We can't get there. If I try to ping these two, it's not going to happen. All right, and let's just test it. First, we ping our gateway. We know we have connectivity to our gateway, 192.168.1.254. We're good. Control C. I'm going to ping now in between. I'm going to ping the 10.1.1.6. Oops. Control C. Oh, there you go. Okay, good. That's the router S001 on the other side. It's not going to go. It's not going to go. Okay? We're not going to waste time. It's not going to go. Because it's not going to come back. And that's what a request timeout means. You got there, but the other router had no idea how to get you back. Unreachable, if that were to say unreachable, you couldn't even get out of your own gateway, your own doorway. So what happened here was that when I ping 10.1.1.6, which is right here, this router says, I don't know you. I have no idea where you're coming from. Because remember, a ping is an echo request, and you need to reply to that, echo reply. So when I ping them, I got here, but this router says, I don't know where you're at. I have no idea where you exist. So he sent a message back that says, request timeout. I don't know where you're at. If it was unreachable, you wouldn't even leave your own gateway. That's what that means. You're not even getting outside here. Okay, so how do we make this work? If you only have two routers like this in a point-to-point, actual point-to-point connection, all right, it's very simple. It's called a default route. And what is that? All right, an IP default route, because when switches create MAC address tables, I'm going to bypass that if you don't mind. I don't feel like typing in passwords. Okay, I'm going to do a Control Z, show MAC address table. Switches make these type of tables. layer 2 tables. Okay, they don't create routing tables, they create MAC address tables. So this gig 01, okay, is oh wow, it's the Jesus Christ. This gig 01, where's gig 01? Oh yeah, right here. It's the I'm sorry. On gig 01, you learn dynamically the MAC address of your router. Okay, inter-networking devices will automatically send what's called bridge protocol data units. They learn each other's MAC addresses the minute you plug them in. All right, end devices like this one, this is the computer, right? On F01, this is the computer's MAC address. They don't learn them automatically. You have to do something. You have to generate an ARP in order for them to learn that address. Okay, so switches, MAC address table. Routers, routing table, layer 3 addresses. Right. Show, not MAC address table, but show IP route. Okay, sorry, MAC address versus ARP. Okay, the ARP table is showing you what you already know. Okay, so if we're to do, all right, so if we go, but let's go back to the switch. Even better, let's go to the computer. Ooh. No. Yeah, I just went blank. Oh, there you go. ARP minus A. Whoa. Oh, lowercase. ARP minus A. So this is showing you already what you've been through. Okay, you've been through the gateway and you've been through the switch. So this shows you that information, the ARP table. That can be cleared. And when you're having issues reaching somewhere, that's one of the things you want to do. You want to clear your ARP cache. So the ARP table is something that they cache or somewhere where they've already been. Okay. The MAC address table also is volatile, where you have MAC address table on a switch only lasts for 5 minutes. If nobody types, everybody goes to lunch at 12. They leave the company, everybody. And nobody's typing on the computers, nobody's going across the network or anything like that. When you come back, you have after 5 minutes. And then you have to ARP again, and then it starts generating the MAC address table. And the MAC address table is just that. It's a table of the devices that it has learned dynamically and maps them to a particular port. And the ARP table is just a cache where you've been through, that's what you're showing it. But again, these are things you don't really want to do clear MAC address table. You want to do clear ARP cache or ARP minus D for a computer. All right, to get rid of that. Now here, show IP route. This is your routing table. We do layer 3 addresses. So here's the network across the serial, which is 10.1.4. And here's what we have beneath us, which is 192.168.1.0. And you see it's a 24-bit mask and 30-bit mask across. So why is it showing us this with a 32-bit mask? It's telling us that on the interface, S00, the IP address 10.1.5 is configured. That's why they masked it with a 32, 255, 255, 255, 255. So we know that that is the exact IP address on that interface. And the same thing happens for this interface. Do you see anything about with the 2? You don't see anything about the 2. We can't reach the 2. And the same thing is going to show you in the other router. It knows about the 2, but it doesn't know about the 1. That's why we can't get to each other. So then we turn the easy way, quick way with 2 routers to do it is to use this. The gateway of last resort. What is that? That's a default route. The static default route. These up here are just legend codes. I said static, right? S for static. I said default. Candidate default, asterisk. That's just to show you what's here. So a C means connected and L means local. Okay? So when we create a static candidate default route, or the gateway of last resort, its purpose is not to drop packets. Its purpose saying, I don't know, I don't have that entry in my network but I'm just going to send you to the next router. Maybe they do. And then the next router will take that. So we need to configure this on both routers. So where do you do it? We're in privilege mode. When we configure, we have to go where? Global configuration, conf T. So we're going to say IP route. And I'll tell you after I do it, 0.0.0, 0.0.0.0, and 10.1.1.2. What does that say? That says, I want you to match whatever network you're trying to get to, whatever mask it has, and I want you to send it to the next router. That's the next router's hop address. Okay, let's enter that. Let's take a look at that routing table again. Let's save it. Do WR, because we're not in privilege mode, we gotta type the do. And do show IP route. So I don't have to go back out. What are you kidding me? Okay, try it again. IP route, 0.0.0, 0.0.0. Next router's hop address. All right, WR. Okay, Control Z. Try it out. All right, that's awesome. I'm gonna go to the other router. It's okay. This happens. This happens. No problem. No problem. All right. Next week, we're going to be using EVNG. Exit, Control Z. Oh, I didn't want to be there. Global config. There you go. IP route 0.0.0.0, 0.0.0.0. Oh, I did it again, didn't I? 10.1.1.5. I did it again. I put the wrong IP address. I keep thinking I'm in the 0 network, I'm in the 4. Show IP route. There it is right there. So it's not the packet tracer, it's Loudril is. Let's do the new one and get rid of the old one. Or maybe didn't put it at all. IP route because of the wrong IP address. So IP route 0.0.0, 0.0.0, 10.1.1.6. The next router's hop address, which is not 2. WR. All right, new show IP route. There it is. Wow, and you can see it up here. And you can see it down here. Static, candidate default, all zeros, all right? And you see this right here. This is an administrative distance of 1, okay? And connected to 10.1.1.6. All right, so we got that going. Let's make sure that there's no other static route in here. Show, run, pipe, section, static, or show route, really. So you see, I had the wrong one in there. So we need to really get rid of that. Config T, so we need to negate it. We type in no, work smarter, not harder. And you can do this in the test too. Copy, paste. Save it. Right, I'm gonna end. I'm gonna do that run command again. And now it's gone. Because it could cause issues. All right, and then nullity, if we can ping across. It helps if you put in the right IP address. It really does. So ping 192.168.2.1. Let's fast forward through time. I don't have time to waste, and we got a reply. So the first one you missed because of the ARP, but now you have that. So again, the ARP cache, like right now, I don't get, you see what's happening? No ARP, right? I don't miss the first one. But the ARP table has that ARP cache, ARP minus D, or minus EA, I'm sorry. And you see that ARP cache. But if I do this, ARP minus D, right? And then I do ARP minus A, there's nothing, there's no entries found. So if I were to ping the same one, we should miss the first one. Well, I guess we don't. Okay, that's fine. All right, but that's what should happen because you don't know, and you needed that in your ARP table. So, but again, this is something that you would do, like for troubleshooting in your home. If you're having issues, there's 2 commands you can do. All right, and I'm going to open it up to questions in a second. All right, one of the things that you can do is CD. Let me go here. TLS. You can do ipconfig // oh my god, DNS. What is it? Oh my god, really? You feel me? No. Release, renew, flush. Here it is. My god, I couldn't think of it for save my life. Flush DNS. If you're having issues getting to websites, whatever, you can go ahead and flush the DNS resolver cache. You get cache every time you go on the website. You get these caches. So if you're having issues that you can't get to it, flush the DNS, and definitely ARP minus D. Right? I don't want to do it here because it's the actual computer, but ARP minus D, and you get rid of all that. So if you're having issues, that's something you may want to get rid of. All right. So I'm going to open it up to questions now. We got 20 minutes. There's Sanjeet. He put the ARP minus A right there. Flush. I got it. It was a typo. I got it. So one site static, one site default route can be configured. Sure. You can do a true static route on one side and then a default on the other. That's fine. Or you can do default on both sides. But again, careful where you do it. If you have multiple links, don't be doing default routes. You want to do actual static routes pointing to networks, not just that 0000. That's just match anything or match any network that comes through here with any mask. You want to say, I want you to stat IP route this network, this mask through this interface. So you do an actual static route. All right. So be careful when you have multiple links. All right. I'm looking. You have any questions? You can unmute yourself if you want to ask a question. We still got 20 minutes. If I have one VLAN, does it make it the switch low? If you have one VLAN and you have a lot of people, so I think I looked it up in Google the other day because nobody really says that. What is the maximum number of VLANs you can have of devices you can have in one VLAN? Nobody says that. So how big can a VLAN get? Okay, so if you're noticing slowdowns on the one VLAN, you should create another VLAN. And let me just show you this because it's really not that difficult. I'm going to go inside the switch. I'm going to hit enter. I'm just going to bypass that because I'm not going to type any passwords. Okay. You want to do, and VLANs could be floors, could be departments, could be whatever. So you have VLAN, you have VLAN 1, right? Let's say VLAN 10, name, HR, my favorite department. VLAN 20, name, payroll, about my second, well, actually it is my first payroll, right? So I did 2 VLANs, do WR, to save. Now I want to look at that. Do, show, VLAN, brief. And there's your VLANs right there. Oh, look, you created a VLAN. Now you need to assign them and all that other stuff, and you can put IP addresses on them so you can manage it as well. But you want to do this, and network a 192.168.10.0, a 192.168.20.0 network is attached to each VLAN. So you're logically segmenting it. So if you notice that you have one VLAN and they're small, definitely you want to break that up. How you want to break it up is up to you. If there's a 48 port switch and I VLAN then, if you have a 48 port switch and you want to do it like this, let's look at the physical. So you can take it and say, okay, these ports right here are part of VLAN 1, let's say. These ports right here are part of VLAN 2. These ports right here are part of VLAN 3. These ports right here are part of VLAN 4. Or if you want to get really crazy, port 1, VLAN 1, port 2, VLAN 2. Every port can be a different VLAN if you wanted to. So you depends what range of ports you want to be part of that VLAN. You can do that in a 48 port switch and just separate them that way. You can do that. It's up to you, really. It's yours. That's more design than anything when you talk, because it's a logical segmentation, a logical breakup of the networks that you're doing. You're going to increase efficiency because, again, what happens in a VLAN stays in a VLAN, even though it's in the same switch, but it's in a different network. But if you do that, you're going to have to do, don't want to get into it right now, but what you're going to have to do on the router is inter-VLAN connectivity. So concerns has a 48 port allowed in one VLAN. Exam VLAN 10 does a 48 port allowed in one VLAN. Example, VLAN 10, does it make the switch slow? The number of ports, again, the number of ports doesn't make the VLAN slow. The number of ports, I told you that where I worked in the brick and mortar, we had like 32 48 port switches. It's not that the switches, because there were 48 ports, were slow, is the fact that we had 32 switches, okay, inside the same VLAN. That could have been a 24 port switch, okay? Could have been a 4-port switch, right? If the amount of traffic on that one VLAN gets very heavy, let's say you work for a company that deals with architect. Let's say I was a land surveyor at one point. So when we would do our surveying on the street, come back, put all that information, so an AutoCAD machine can go ahead and make the drawing. Okay, those packets are huge, huge. So if your company is just that, and you have 32 switches with 48 ports, and that's the type of traffic that's going back and forth in one VLAN, that's a problem. If you have 32, 48 ports, VLANs, right? They're in VLAN 1, but people are just playing solid, well, people are just sending documents back and forth, that should not be slow. That should not be slow, okay? But again, what type of traffic is going through there? You got to analyze that. What type of traffic is going through there? And again, the amount of people on that VLAN, the amount of devices, not people, the amount of devices on that VLAN. That's all. That's all there's to that. That's all there's to that. But again, when we start doing VLANs, you saw I just created VLANs for you. No big deal. You're welcome. You're welcome. All right. But it's no big deal. But the navigation right now is my concern, right? Make sure that you know how to navigate through these things. Look at these videos. But if you have any questions, I'm here. We have 10 more minutes. If you have any questions on anything we've done from previous class, this class, tell me. I'm here to answer your doubts or concerns. Okay? I really don't want to keep going. I said I was going to do SSH. I could. Just showing you because it's really not that difficult. We did telnet, right? So to do SSH, I'll just do it on one router and show you an example. Okay, that will be the other thing that's on that notepad. So we turned on telnet already. It's already on. We know that. And we said transport input all that will allow SSH. And we don't, but we need a couple things still in order to do SSH. One we have, which is a host name, right? The next thing we need is a domain name, IP domain -name, Cisco.com. Okay, because it's going to take r1.cisco.com to create keys to encrypt the traffic. So last day I asked about uplink and trunk port. What is the configuration for an uplink port in a switch? I really don't know what a configuration would be for an uplink port per se if you're doing an actual uplink. Unless it's an ether channel and you're creating, you're doing, making them layer 3 ether channel and you're putting an IP address on there, that would be an uplink, I guess, would be that. Or you're doing routing on a layer 3 and you have to put IP addresses on that. But as far as putting an actual configuration for uplink, that's kind of confusing. As far in a switch, what you would do for trunk ports, because that's an encapsulation type. This is a router. Let me just show you a switch real quick. Okay, so on a switch, config T, You just pick any port, interface F020, whatever. We could do switch port mode trunk, right? But what that does is it does this. Let me show you. DWR, initial int trunk. It just, no, it doesn't show it. No, there's nothing connected to it. But what it'll show the encapsulation method, which is 802.1q. All right, in order for the VLANs that we created to go through there. Because what we saw here first was VLAN 1, right? Show VLAN brief. We saw VLAN 1. VLAN 1, the native VLAN, is the only VLAN that can go across trunk ports or access ports. Again, uplink for me is a generic name. If there's an actual uplink port in these configurations, I don't know. All right, but as far as switch to switch without VLAN can be uplink, you can call it that. You can call it that. You can have two switches connected to each other. All right, and then you have one VLAN, the native VLAN. The native VLAN is the only one that can go across access ports. Let me show you something. Show switch port. No, show interface G0/1 switch port. Let me show you that real quick. I'm just looking at this interface, this right here. Okay, so you see how their access, the operational mode is static access. So the only VLAN that can go across there is the native VLAN. The native VLAN. That's the only one that can go across there. All right. So if you have two switches connected together, sure. Okay. If you have this, and I'm going to use a lightning bolt to cheat. If you have that, you can be VLAN 1 here, VLAN 1 here. They have to be the same network. Okay. But that's a problem. And when we get into that, you see how this is amber? Let me maximize that a little bit. Yeah, zoom in there. You see how that's amber right there? If you have this and you don't have ether channel, okay, what's going to happen is that, and then that's just a configuration. That's all it is. It's terms. All right. Spanning tree, which is a protocol at layer 2 of the OSI model that's preventing loops from happening, you're going to get this. Okay, you're going to get a block port. So it could be slow if you have this and everybody's in VLAN 1. It could be slow because you're really not using all your throughput. If I were to plug in another cable, look what happened. It blocks that one too, because spanning tree is not allowing you, these ports are blocked. It's not going to receive anything. It's not going to forward anything. So traffic is only passing by that cable all the way in the back. So really you're only using one cable. So in order, if you want to increase your throughput, if this is the situation you have, and all you have is VLAN 1, you need to create something called, depends on the switch you have, layer 2 or layer 3 ether channel. All right, and then it'll aggregate these three and they work together, which will bypass spanning tree. Spanning tree won't see it as 3 different lengths, they'll see it as 1. And then you can get increased throughput, but that's ether channel. So as far as uplink configuration, I've never done anything that's uplink configuration. Trunking the ports, okay, I'm taking this switch, is my distribution switch, and this is my core switch. Then I'm creating an uplink, then that's, you're connecting it to this switch. Or if there's an actual port that says uplink, and you're in a stack-wise configuration where all these multiple switches, like 9 switches, work as one, and they have an uplink between them, then at that point, okay, but then you talk about software. I hope that's answering your question. I'm looking at the chat. Okay? But the ether channel comes right after the VLANs and spanning tree. Once we create VLANs, once we deal with spanning tree, we'll go ahead and do ether channel to show you how to fix that issue on there. Any other questions? Can we use stack cable instead of uplink? Yeah. Yeah, why not? That's what you need to be doing if you have a stack-wise. Yes. Yes, sir. All right. All right, it's 1. All right, next week, we're going to be we're going to start creating VLANs. We're going to start creating VLANs. All right. And with multiple VLANs, you're going to start using trunk ports. So we'll talk about trunk ports. We'll talk about the VLANs and things that happen. Okay. And we do intra VLAN connectivity. So we're going to do a nice little, cute little app, and we'll start talking to multiple networks and configuring these multiple VLANs. Okay. But again, and when we talk about trunking, we'll talk about, because only VLANs we create go across trunk ports. You're quite welcome. You're quite welcome. All right. So next week, VLANs, practice this, please. Practice the navigation to the packet tracer. Try to create your own labs. I don't know if you can share it and then I can see it. I don't know how that works. But just ask the network kings if we can have one-on-one calls or whatever. I don't know. I don't know how that works. But find out. But you need to read and you need to practice these labs. If you wait till next week, everything we did today or yesterday, you'll just forget. Okay? All righty.